Hello, and welcome to the directions video for the force lab using the spring scale or fishing scale. Okay, so here we have our scale. This is my object, which is a nice heavy pan, in this case a cast iron pan, which I found works very well, but you can use other objects and you can kind of comment on what works well. All right, so let's go ahead and turn our scale on. Okay, so the first thing we're going to do is simply hang the object from the scale. This is going to give us its mass, all right, or a mass reading in quotes, right? Of course, what it's actually reading is force. Okay, I gotta get that on there. All right, so there we are. Okay, now we'll go ahead and lift this up. All right, so there we go. Okay, kind of hold it at rest. And these scales, at least this kind, will lock in place, which isn't the best. You often have to kind of unlock it. To unlock the measurement, you simply push the on-off button. But you can see here that our rest mass is 2.25 kilograms, but of course the scale is actually measuring force and doing a calculation, which I asked you about, okay? So you're gonna do that, and then additionally you're going then to accelerate the scale up and down. So if we have it hanging again, and then we go ahead and push the on-off button. Okay, so let's go ahead and do that. Okay. So then it'll be in movement again, and I can quickly accelerate it up and get a certain reading, quickly accelerate it down and get a different reading, right? And you'd want to do that in frame. Okay, and you can just look at those individual images. You don't have to export the file or anything. You just have to look at individual frames, make sure your lighting's correct so you can actually see the numbers, obviously. But you're gonna accelerate that up and down and get the different mass readings while it's accelerating and calculate the acceleration from there. That's part one, okay? But now let's talk about part two of the lab, okay? So I should have no force acting on the scale, okay? Zeroes out again. And in part two, you're just gonna pull things, okay? So I'm just showing one surface here, kind of this wooden butcher's block, and I'm gonna pull on the object. You're gonna pull exactly parallel to the surface, and you're gonna find the moment that it starts to move. And based on the required mass reading, you're then going to calculate the force that it took to pull the object. There we go, all right? And you look at that particular frame, and you look at the frame that shows just the beginning of the movement of our object here, and look at there, it locked in place, but we can just unlock it. So you look at that frame that corresponds to the beginning of the movement of the pan, and then find the particular mass reading and calculate the force from that mass reading. And it locks in place when it stops, when there's no action, right? So if I pull on it gradually until it moves, okay, there we go. Okay, so you're gonna do that 6 times to get a nice average, okay, for this particular combination of surface and object. Then you're going to pull at an angle. And you're gonna measure that angle using a protractor or using measurements. And the angle might look something like this. This would be the angle above the surface, okay? And when I pull at above the surface, I will observe a different mass reading, quote unquote, that allows the object to start moving, okay? And if I pull below the surface, I should get a different reading still. It might work well to pull below the surface if you're after the edge of the table, all right, or beyond the edge of the table, that way you can get a good pull below, okay? And then you record that mass reading. A couple of words of advice about the equipment and making it work well for you is you want an object that's not gonna tilt easily. That's why I'm using cast iron, because it's particularly dense. So it's gonna pull across the surface rather than starting to tilt. Basically a stainless steel pot is gonna tend to tilt because it's not nearly as dense. You can deal with that, and the tilting is only a concern in procedure 2, but you can kind of alleviate that concern of tilting by putting something heavy inside the pot. You know, it's putting like a big brick inside it or something. You know, maybe wrap it up so it doesn't damage your pot. But you know, obviously, you know, you can increase the mass. Then you would have to know that mass though, because it'd be different than the hanging mass. So just take into account if you are adding weight in order to prevent tipping to say a stainless steel pot or whatever you find is convenient to pull. Then you know that's definitely take that into account for your kind of your original rest mass of your object. Okay. Furthermore, the nice thing about this cast iron pot is that the handle is kind of parallel like this. It's not tilted up or anything. You may not be able to find that, but that is ideal. And really that's about the only consideration. And you're going to do, you know, repetitions to get a nice average of the force it took to start the object pulling when it was parallel, when it was angled up, when it was angled below. You're going to do 6 repetitions, so 18 pulls, 18 measurements, just that you collect off your phone, write them down somewhere or type them up into an Excel file. And then you're just going to do the same thing all over again with the same object, but on a different surface. Say, for example, put this on carpet instead of wood. And that's really it for the lab. Just a few analysis questions, I think some that make you really think about the nature of the data, and some opportunities to draw some free body diagrams. All right, well, thank you so much for watching this directions video.